Myself, Dr. Sandeep Kumar, Assistant Professor, Department of Chemistry, Ramjas College, Delhi University. Dear friends, today we are going to discuss heterocyclic compounds. Heterocyclic compounds play an important role in our daily life. As you can see in the first slide that these compounds are very important in many food items, in medical field and daily usage things. So, like caffeine itself is an heterocyclic compound, then again many antibiotics also are made of heterocyclic compounds. Hair dye and many things which we use in daily life are made of heterocyclic compound. So, in this course, we are going to discuss about the basic introduction of heterocyclic compounds, biological importance of heterocyclic compounds, thereafter classification of heterocyclic compounds, then nomenclature of heterocyclic compounds. After discussing these four parameters, then we are going to discuss 7 different heterocyclic compounds. Those will be pyrrole. In pyrrole, we are going to discuss synthesis of pyrrole, its physical properties and as well chemical properties. After pyrrole, we will discuss furan, and again we will discuss the synthesis of furan, its physical properties and chemical properties. After furan, thiophene, then pyridine, thereafter indole, quinoline and isoquinoline. So, in this way we will discuss these 7 heterocyclic compounds which are which have significant role in chemical field as well as in our daily life. So, let us start with the basic definition of heterocyclic compound. As the name suggests, hetero means different and cyclic means cyclic ring. So, how we can define heterocyclic compounds? The cyclic compounds that contain one or more heteroatom other than carbon are known as heterocyclic compounds. The common heteroatom found in these heterocyclic compounds are nitrogen, oxygen and sulfur. Other than these heteroatom, you can see phosphorus, boron, silicon and selenium as well. So, in this course, we will discuss these 7 heterocyclic compounds like pyrrole. So, pyrrole is a 5-member heterocyclic compounds with nitrogen as the heteroatom. Next, we will discuss furan. Furan is again a 5-member heterocyclic compound, but in this heterocyclic compound, the heteroatom is oxygen. In thiophene, it's again a 5-member heterocyclic compound, and in this case, the heteroatom is sulfur. After this, we will discuss pyridine. So, pyridine is a 6-member heterocyclic compound, and it has nitrogen as the heteroatom. Thereafter, we will discuss 3 fused heterocyclic compounds. So, in fused heterocyclic compounds, there are 2 or more than 2 rings are fused together. Like in indole, there are 2 rings fused like benzene and pyrrole, which are fused together. In quinoline, it's benzene and pyridine which are fused together, and isoquinoline is another isomer of quinoline which has benzene and pyridine rings fused together. So, in this course, we are going to discuss in detail about these 7 heterocyclic compounds. So, let us start with biological importance of heterocyclic compound. So, heterocyclic compounds play a vital role in our daily life, and a wide range of them are naturally occurring. So let me explain you how these are playing role in our daily life. So I have divided the role of these heterocyclic compounds into 4 categories. The first category is carbohydrates molecule. I will say that carbohydrates molecule are heterocyclic compounds. Why we are saying this? Because in carbohydrates molecule you will see that all carbohydrates molecules have pyran or furan as the unit in their core structure, and we know very well that carbohydrates molecule serve as biofuels for all kind of living organisms, and they can be considered as oxygen containing heterocycles, as can be seen in pyranose form and furanose form. The another application of these heterocyclic compound is can be seen in chlorophyll and hemoglobin. So we know very well that chlorophyll is responsible for the green color of leaves and hemoglobin is responsible for the red color of blood, and these both molecules are essential for sustaining life in plants and animals. So these compounds are the examples of nitrogen containing heterocyclic compounds, because in their core structure pyrrole is the unit which is there in their core structure. So we can say that these chlorophyll and heme are also examples of heterocyclic compounds. Further, the role of heterocyclic compounds can be seen in medical field as well. So as we know, penicillin is a famous antibiotic medicine which is again a heterocyclic compound. In penicillin you will see that the penicillin is made of 2 heterocyclic ring. One is 4-member ring and another is 5-member ring, and they have nitrogen and sulfur as the heteroatom. You will see in this case. Then the second example in medical field is vitamin B, that is thiamine. In thiamine, the molecule is made of 2 heterocyclic ring. In one ring there are 2 nitrogen atom, we call it pyrimidine, and in another heterocyclic ring there are nitrogen and sulfur as the heteroatom, and we call it thiazole. So we know very well about the importance of vitamin B, which is essential for our body. And the third example in medical field is nicotine. So nicotine is again an heterocyclic compound which has pyridine as the heterocyclic ring and pyrrole also as the heterocyclic ring. So nicotine is found in tobacco. Further, the fourth category of for the biological importance of heterocyclic compound is can be seen in the form of DNA and RNA. So DNA and RNA are essential part in our body, and they are made of nucleosides molecule, and we know that nucleosides molecule are further have 2 components, sugar and nucleobase. So all kind of nucleobase have pyrimidine and purine as the core unit in their structure. So for example, you will see uridine and adenosine. In uridine there is pyrimidine nucleobase present, and in adenosine there is pyrimidine as a nucleobase present. So in this way we can say that heterocyclic compounds are playing very important role in our daily life. In fact, we are surrounded with heterocyclic chemistry. Further, we will discuss about the classification of heterocyclic compound. So all kind of heterocyclic compounds are classified into 2 categories. Either these compounds are non-aromatic compound, the first category, or we can say alicyclic compounds, or these compounds may be aromatic heterocyclic compound, and they must follow the Huckel's rule, that is 4n plus 2 pi rule. So one by one we will discuss about these two type of heterocyclic compounds. The first is non-aromatic heterocyclic compound. So non-aromatic heterocyclic compounds can be defined as alicyclic compounds that contain one or more heteroatom within their ring structure are referred to as non-aromatic heterocyclic compounds. You will see some examples from this category, like if there is a 3-member ring and oxygen as the heteroatom, then we call it oxyrane. If the ring size is 4-member ring and oxygen as the heteroatom, then we call it oxytane. Further, the ring size is 5-member and oxygen as the heteroatom, then it is tetrahydrofuran. Further, ring size is 6-member ring and oxygen as the heteroatom, then we call it tetrahydropyran. In similar way, this is applicable for when there is nitrogen present. So if nitrogen is there as the heteroatom in 3-member ring, then we call it azridine, and in 4-member ring we call it azitidine, in 5-member ring pyrrolidine, in 6-member ring if nitrogen is there then piperidine, and in case of sulfur as the heteroatom, then in 3-member ring we call it thiarine, thiethane for 4-member ring, and tetrahydrothiophene for 5-member ring. The second category is aromatic heterocyclic compound. So aromatic heterocyclic compounds may be defined as the cyclic compounds that contain one or more heteroatom in their structure are known as aromatic heterocyclic compound. You will see some example from this category, like if we have 5-member ring with unsaturation, then we call it furan and it's an aromatic heterocyclic compound. If there is nitrogen in 5-member ring and the ring is unsaturated, then it is pyrrole. In case of thiophene, the heteroatom is sulfur, and in case of pyridine, the heteroatom is nitrogen and the ring size is 6-member ring. So these are the examples of aromatic heterocyclic compounds. Further, the aromatic heterocyclic compounds are classified into 5 classes. So these 5 classes have been divided on the basis of 2 parameters. The first parameter is on the basis of size of the heterocyclic ring, and the second parameter is on the number of heteroatom present. The first category in this case is when the ring size is 5-member ring and that has only one heteroatom present. So you will see some example, that is furan, it has 5-member ring, and oxygen, that is only the heteroatom present in this ring as in this category, that is furan, pyrrole and thiophene. The second category in case of aromatic heterocyclic compound is when the ring size is 6-member ring and that has only one heteroatom. So you will see the example of pyridine, that is 6-member ring and nitrogen as the heteroatom. Further, the third category in this in the classification of aromatic heterocyclic compound is when the ring size is 5-member ring and they have 2 heteroatoms. So in this case, when the heteroatoms are oxygen and nitrogen, the most important thing is that these heteroatom can be of same type or they can be of different type. So when they are different, like one is oxygen and the another is nitrogen, then we call it oxazole. And if both heteroatoms are same, just like they are nitrogen and 1-2 position separated, then we call it pyrazole. And in case of imidazole, both the nitrogen are 1-3 position separated. So the fourth category in this class of aromatic heterocyclic compound is when the ring size is 6-member ring and that has 2 heteroatom. So in this case you will see 3 examples where the 6-member ring has 2 nitrogen present, but they are different in case of their position. So in case of pyrazine, both the nitrogens are separated by 1,4 position. In case of pyrimidine, both the nitrogens are separated by pyrimidine. And in case of pyridazine, both the nitrogen are separated by 1,2 position. The last category in aromatic heterocyclic compound is fused heterocyclic compounds, or we can say them condensed heterocyclic compounds as well. So in fused heterocyclic compounds, there are 2 or more heterocyclic ring or benzene rings are fused together. Just like in case of indole, there are 2 rings fused, one ring is benzene and the other ring is pyrrole. So this comes under the category of fused heterocyclic compounds. In case of quinoline, there are 2 rings fused, one is benzene, the another is pyridine, and this also comes under the category of quinoline. So in this way we can classify aromatic heterocyclic compounds into 5 categories. Further, we are going to discuss the nomenclature rule for the naming of heterocyclic compound. For the naming of heterocyclic compounds, we have to follow some specific rules. So these rules are, the first rule for the nomenclature of heterocyclic compound is that the size of the ring is represented by a specific stem. So we need a particular or specific stem for on the basis of size of the ring. Suppose the size of the ring is 3-member or 4-member or 5-member, then each ring size will have a different stem. We will see this in the next slide. Further, the second rule is that after the stem we have to add a specific suffix, and before the stem we have to add a specific prefix. So for that, the second rule is that a suffix is added to the stem based on the presence or absence of nitrogen. Whether the ring is has nitrogen or not, that will depend, and whether the ring is saturated or unsaturated, that will also depend to decide the suffix for that particular heterocyclic compound. The third rule is for the choosing for prefix. So the heteroatom in the ring are indicated by specific prefix. So for example, if oxygen is there as the heteroatom in the ring, then oxa will be the prefix. For sulfur, thia will be the prefix, and for nitrogen, aza will be the prefix. So now we have all 3 components to decide the nomenclature of heterocyclic compound. So we have to keep stem in between and suffix at the last and prefix at the beginning for the naming of heterocyclic compounds. You can see in this table, so in this table the first column represent the ring size, that is if the ring is 3-member, 4-member, 5-member, 6-member, 7-member or 8-member. And on the basis of ring size there are specific stem. For example, if the ring size is 3 member, then the stem is IR. If the ring size is 4, then there is ET as the stem. If the ring size is 5, then all will be the stem, and for 6 member in, for 7 member EP, and for 8 member OC. And the second rule was that we have to choose a specific suffix. So for choosing specific suffix, it will depend that the ring has nitrogen presence or not. So the second and third column are that whether the ring has nitrogen or not. So with nitrogen and without nitrogen. Further, that has been breakdown into whether the ring is unsaturated or saturated. So when there is nitrogen is present in the heterocyclic ring and the ring is unsaturated, then for the 3 member ring we will choose irene as the suffix, and for 4 member ring ET, and for the 5 member ring all, for the 6 member ring in, and for the 7 member ring epene, for the 8 member ring okane. Similarly, for the saturated heterocyclic ring with nitrogen as the heteroatom, we will choose iridine as the suffix for the 3 member ring, etidine for the 4 member ring, and olidine for the 5 member ring. In similar way, when the ring do not have any nitrogen in their heterocycle ring, then whether the ring is unsaturated or saturated, we are going to discuss about the suffix. So for the unsaturated system, if the ring size is 3 member ring, then irene will be the suffix IRENE in this case, and ETE will be the 4 member ring, and OLE for the 5 member ring, IN for the 6 member ring, epene for the 7 member ring, okene for the 8 member ring. In similar way, nitrogen with without nitrogen with saturated system, irene for the 3 member ring, etane for the 4 member ring, olane for the 5 member ring, ane for the 6 member ring, epane for the 7 member ring, and okane for the 8 member ring. So now we should be ready for the nomenclature of heterocyclic compound. So while doing the complete name of heterocyclic compound, we have to drop a letter from the prefix. For example, if the ring size is 3 member ring and oxygen is there as the heteroatom, then the stem plus suffix will be irene, and the prefix for the oxygen is oxa. So the complete name of this heterocyclic compound will be oxyrene. In similar way, if there is 3 member ring with nitrogen, then the suffix will be iridine, and prefix for nitrogen is aza. After dropping a from aza, the complete name will be azridine. So in this way we can do the naming of all kind of heterocyclic compound. So you can take the example of pyridine. So in IUPAC nomenclature, the suffix for 6 member ring that is unsaturated and has nitrogen as the heteroatom, the suffix will be ene, and the prefix for nitrogen is aza, so we call it azine. So in this way we can do the nomenclature of any heterocyclic compound. Next, if the last rule in this category is that if there are more than one heteroatom present in the heterocyclic ring, so we have to choose some priority order. So for that if the atom belongs to higher group in the periodic table, that will be given priority, and if the heteroatom are from the same group, the one with the lower atomic number takes preference both in naming and in numbering. So, in case of oxygen, sulfur and nitrogen, the preference order will be oxa, thia and aza. So, you will see in these two examples, like if there are oxygen and nitrogen as the heteroatom, so we will give preference to oxygen in both naming and numbering. So, the complete name of this compound will be 1,3-oxazole. So, thank you very much for watching this.